All right, let's dive into what is, without a doubt, a pivotal moment in economic history. The year 2026. Why? Because this is the year that the line between science fiction and a corporate P&L statement, well, it just completely disappeared. We are talking about the moment humanoid robots became not just a cool idea, but a profitable reality. And really, it all boils down to this one incredibly stark comparison. On one side, you have the total cost of a US warehouse worker, which comes out to about $28 an hour. And on the other side, the hourly cost to run a humanoid robot in 2026, $5.71. This isn't just a small discount, it's a full-blown economic shockwave. It's the one fact that creates an almost irresistible pull towards automation. So how did we get here so fast? The rise of the robot isn't just about a sudden tech breakthrough. It's also about a huge worldwide labor problem that was screaming for a solution. We were basically staring down the barrel of a perfect storm. First, you've got this silver tsunami, a massive wave of skilled manufacturing workers hitting retirement, leaving this giant hole of experience. At the exact same time, there's all this pressure to reshore manufacturing, to bring it back home. But here's the paradox. The labor we have at home is just too scarce and way too expensive to make it work. And that's where the humanoid robot has its killer app, the Brownfield advantage. You don't need to build a brand new custom factory. These things are designed to walk right into the buildings we already have. It's also super important to get that this isn't just about better nuts and bolts. The brains have had a massive upgrade. What we're seeing is this incredible convergence of IT, that's all the software, the AI models, and OT, the operational tech, the actual motors and sensors in the real world. They're calling it physical AI. And what it means is that these robots can now learn just by watching and by running simulations. They're moving away from rigid one-task programming to actually being able to adapt and solve problems on the fly. But for any of this to actually happen, the numbers had to add up. The economics had to work. For years, humanoids were stuck in research labs because they were just too expensive. A critical cost barrier had to be broken. And this is it, $25,000. That was the magic number. Hitting this price point is what turned the humanoid robot from a super cool science fair project into a real commercial asset you could actually put on a balance sheet. All of a sudden, the math for replacing human labor didn't just look interesting, it looked inevitable. Now, this is where it gets really fascinating. When you break down that 25 grand price tag, you can see where the real challenges were. The biggest ticket items by far are actuation, that's all the motors and drives that make it move, and the hands, which are just incredibly complex pieces of engineering. So getting that total cost down meant getting super aggressive, vertically integrating, and borrowing a lot of tricks from the EV industry's supply chain. And you can see a perfect example of this innovation just in the power system alone. Companies took totally different routes. While reports were suggesting Tesla was running into some major headwinds trying to scale up its 4680 battery cells, Figure AI had this huge breakthrough. They figured out how to integrate the batteries directly into the robot's torso, which gave them a whopping 94% jump in energy density and slashed the cost by 78%. Just a game changer. Okay, so how does this all come together in the real world? Well, 2026 is the year these robots finally escaped what people in the industry call pilot purgatory. They got out of the lab and started working full productive shifts on actual factory floors. And the gold standard, the place where this all became real, is the BMW manufacturing plant down in Spartanburg, South Carolina. And we're not talking about a little test run in the corner here. We're talking about operational dependence. This is the case study that proved to everyone that the technology was finally ready for high-stakes, precision manufacturing. And the numbers, the data coming out of there is just staggering. The fleet of Figure robots handled over 90,000 parts. They contributed to making 30,000 cars. They're running 10-hour shifts every single day with a placement accuracy rate of over 99%. These things aren't just capable. They are unbelievably reliable and consistent, even at a massive scale. And that reliability all comes down to one key metric: interventions per shift. That's just a fancy way of saying, how many times did a human have to step in and fix something? For a robot to achieve 0 interventions, that is the absolute holy grail of automation. The BMW project proved it wasn't just some dream on a whiteboard. It was actually possible. And look, this isn't just happening in the car industry. Over in logistics, you've got Amazon, which has laid out this incredibly ambitious plan to replace over 600,000 jobs by 2033. They're putting robots on repetitive tasks and, in a pretty clever PR move, are rebranding this direct replacement as collaboration. So whenever you have a disruption this big, this fundamental, you're going to get a massive economic shift. It's nothing less than a great rebalancing of capital and labor, and it's creating a whole new class of industrial winners while leaving a lot of others scrambling to figure out what's next. The winners are pretty clear. You've got the vertically integrated robot makers like Figure AI that control their whole tech stack. You've got the critical suppliers like NVIDIA providing the AI brains. And of course, you've got the early adopters like BMW who are already seeing these huge efficiency gains. And the losers? Well, the whole business model for low-skilled temp agencies is basically collapsing. And those offshore manufacturing hubs that built their entire economy on cheap labor, their main advantage is just evaporating. And if there was any doubt left, this table is pretty much the final word. This is the whole economic argument in one slide. The robot's hourly cost just crushes U.S. labor. It can work for more than twice as long. And here's the most important part. Its costs are going down as production scales up, while human labor costs just keep going up. With the return on investment of just over a single year, the financial case becomes completely undeniable. As the report we're drawing from so powerfully puts it, the software has grown legs, and it is running faster than the human economy can adapt. Wow. I mean, that one sentence just perfectly captures the incredible speed and the massive scale of the shift we're all living through right now.
So we've laid out the business case. We've shown you the numbers on the profit and loss statement. And they are crystal clear and they are incredibly compelling. But it leaves all of us with one final, unavoidable question to think about. This is the P&L. What's the human cost?